Okay. One thing, when you use Q4 window, one thing is important. That is, please put all the variables in your model formulation. Put all the variables to the left-hand side of the equality or inequality. And then numbers will be put on the right-hand side of the equality or inequality. So if your formula look like this, if this is your constraint, one of your constraints, how to transform this model to make it readable by the computer. One principle: all the variables should be put on the left-hand side, and all the numbers on the right-hand side. It seems that it's okay, but actually it's not. You have to transform it. So just shift the term and the shift again. So in your computers, when you use Q4 window, it will ask you to type the coefficient of x1, coefficient x2, and the equality or inequality, and the right-hand side value. So in computer input, you can type 1 minus 1. 这是电脑解的时候会这样输入。So if your original formula looks like this, you have to transform into this way. Because if you write this, computer cannot tell whether it is what's this. You have to make some transformation. So this is one principle. Another principle is that you don't have to transform the model into the standard form. 就是你不用把模式转换成标准型 because the computer software will do it themselves. Another principle, you don't have to type non-negativity constraint because computer software will know. We always have a non-negativity constraint. 就是 x1、x2 大一点，你这种非负限制就不要写在电脑那个。就你用电脑考的时候，就不用去打那个非负限制，因为电脑它已经知道这是预设的，然后也不要打标准，然后遇到这种情况你要移下。That's a principle. Okay, let's see an example if the ratio of the production of product one to the production of product 2 and 3 must be at least 2 to 1. In this is a problem. It describes a constraint like this, or requirement of production. Production of a product 1 into the production of product 2 and 3 must be at least 2 to 1, the ratio. Assume we have 3 decision variables. Decision variable 1, x1, is the amount of product 1 to be produced. x2, product 2, x3, product 3. How to write this? How to write this into transform this word description into math. 如何把这个文字变成数学？因为我 x1、x2、x3。x1 比x1的产量相对于 x2 加 x3 要少，它比是2比1的。How to? Hey. Tell me the formula. You are in front of me, so I ask you. You can help, call help from others. X1, E1, X1. Oh. Oh, divided by 2 的，它习惯一些 divided by what? By x3, okay, equal to must at least not at least mean. At least greater than equal to or equal to, greater than or equal to, yes. And I continue to ask you how to transform this formula so that our computer software can read, can know what we want to do. Okay, Daniel, you are so good, so I give you 2 cards. So, in your Q&A window, you will type input values. Q&A window 1输入值就是这样，然后是 x1、x2、x3。This is the equality or inequality, 等号不等号 and this is the value on the right hand side of the equality. Or in chapter 3, we call this value is constraint quantity value of this value. Constraint quantity value. 限制式的值哦，就是指等号不等号右边。Constraint quantity value. One concept that is important. Remember, last week we run Q&A window. Do you see this word? View. 上礼拜我们跑那个作业，你有看到这个 view? Dual value. Dual value is very important in Chinese 队友。But if you think this is too difficult, just think it is the marginal value of a given maybe resource. Or sometimes we call marginal value. 边际价值。What's this? This is the unit value of a given resource. Maybe labor resource or material resource or something. So if the dual value is 1.5, it means the increase of 1 unit of the resource will bring in 1.5 value to the company. For example, let's see if we have a labor contract. Assume we produce 2 products and we only have 40 hours of labor. It's labor contract. And the computer software tells you the dual value is 1.5. That means the increase of 1 unit of labor, 1 unit of labor resource will produce 1.5 value for the company. That value normally is the profit. So 这是资源的边际价值，一单位的劳动资源，如果丢位1.5，代表说一单位的劳动资源可以贡献1.5单位的价值，通常是对利润的价值。So this concept, just keep in mind. In chapter 3, we will use this concept. And why we learn this? Because sometimes we don't have to calculate a lot to obtain a solution. We can directly know the answer. For example, if I ask you if our labor increased by 10 units, 如果我们的劳动力提升10单位 ，how much profit will increase? 你的利会增加多少？利润会增加多少 ？1.5 plus 10. We can know the answer quickly. 所以如果问题现在问你说，如果我现在劳动力多10单位，然后问你说利润会增加多少，你就立刻可以知道答案。Because 10 unit increase, 1 unit, the marginal value 1.5, so 1.5 multiplied by 10 unit increase, 15 profit increase. So this concept, just keep in mind, is a dual value. Dual value means marginal value for a resource. A different resource will have different dual value. For example, if I have another one is the material resource. Assume look like this. Assume the material resource. 这是物料层，物料的资源，这是 clay resource. And I tell you the dual value for the clay. The dual value for the clay. is 0.7。土的边际价值是0.7，年就是物料的边际价资源，物料也是资源。The unit price, the dual value for the material resource is 0.7, and the dual value for the labor resource is 1.5. And one question asked you, which kind of resource is valuable? Much more valuable. 哪一个资源比较值钱？哪一个资源比较值钱？是 labor or material? Which resource is more valuable? The material or labor? Which one? It's easy. Which is bigger? Labor. So labor is more valuable. 哎，这是题目会考的，因为问你说这两个资源哪一个比较值，这看就是你看不懂是不知道，看就知道了。So in chapter 3, we will calculate dual value by computer. In the test, in the exam, I will show you a table, computer output 跑出来的报表。And on the table, you will see dual value for each resource, and one question will ask you, which resource is valuable? You must tell which one. Okay, again, if a question now change, it asks you if we increase the material resource by 20 units. What change to the profit? What's the profit? What profit change? 如果我们增加 material 20单位，利润现在会增加多少？嘿 it's easy. Okay. 乘法 multiplication is easy. For profit will increase by 40. So that's why we teach this concept. This concept is very useful. When you know the dual value, or you can estimate what change will to the profit if we increase in resource or if we decrease resource. 如果我们知道对偶值或是边际价值的话，我们可以估计说资源的增加或减少对利润的影响，就可以立刻知道。You don't have to recalculate， 你就不用再重新再算一次。This is a very useful concept. Okay, now we will step into chapter 3, the most difficult chapter. But just relax. In English course, in chapter 3, I don't use hand calculate problem in the midterm or final, in midterm. I only will ask some problem that will require you to see the computer output and try to explain. 第3章的考法就是看电脑报表，然后你要回答问题，不用手算，因为手算太难。This chapter is difficult because I teach in English, so it's very difficult. Even I teach in Chinese, some of you may not understand. Unless you are good at mathematics. Okay, this chapter 3. Chapter 3 is sensitivity analysis. Abbreviation is SA. What is the definition again of sensitivity analysis? If you don't know everything in this chapter, at least you know the definition. It's very helpful for you. 请问一下敏感度分析的定义。In chapter 1, we mentioned this. Do anybody know the definition of sensitivity analysis? Whether the change of what? Whether the change of what will change the what? Oh, solution. Good. Find the solution. What's it? It's older statistic. Yes. The parameter. So parameter definition is the value that is assumed to be unchanged. 就是原本假设不变的数。So in linear programming, we will see there are some different types. For example, Beaver Creek example again. Beaver Creek, Paul and Mark example. You will see this example several times. Okay, I ignore the non-negativity abstraction. So, how many parameters we have? In the objective function, where are parameters? 在目标函数中，现在的它所谓的参数是什么？你看，是这个吗 ？No， 是变数 ，is variable。哎，是这个吗 ？Yes， 这个是 parameter，this is parameter， 这是 yes parameter。So in linear programming, if we focus on the objective function, we do the sensitivity analysis. We will see whether the change of the coefficient of the objective function or the unit profit, whether the change of the unit profit for each product will change the solution. So this is a question type 1, the most easy one. 就是我们常见的问题是看目标函数的这些系数改变会不会让解改变。In chapter 2, we discussed that. We briefly discussed the slope change, right? And let's see the model constraint. How many parameters we have? Where are the parameters for this model constraint? 参数在哪里 Where are the parameters? This one, and this. So this chapter, we have different questions. One question will ask you whether the change of the coefficient 系数 in the objective function will change the solution. Another question is whether the change of the model constraint value 限制是值的改变，就是不等式。右边的这个值的改变 ，whether the change of the model constraint quantity value will change the solution. Another one is whether the change of the coefficient of the model constraint will change the solution. So this chapter is difficult because the problems are like the parameter change in model constraint. Normally, the calculation process is very complex. So why we use computer software? That's because it quickly can get the answer. And why we need to do sensitivity analysis? Why we assume parameter, we want to do the SA because in practice, all parameters can change, right? Assume you are a manager. Today, the unit price for product 1 is 40. And maybe 1 year later, your manager tells you, oh, customer don't buy product 1, so we decrease our price. So X1's coefficient may be 30. So it asks you, what if I decrease the price of X1 to 30? And you are an operation management manager. You will use sensitivity analysis. Tell your boss whether this will change the original solution. What's the profit level? Another reason is in practice the parameters we have estimate bias, right? 在实物上，在估计这些差数会有一些误差，所以我们为什么要做敏感度分析？就是因为在看这误差的影响下，会不会值会波动？就跟统计学有点像。So this chapter is very useful in practice. 实物上这一章最有用。If you learn how to use computer to solve problems, it helps you a lot. For example, a computer will tell you, oh, for this coefficient, this is P1, a unit profit for the first product. Okay. The range, you have a sensitivity range. Computer software tell you, oh, the sensitivity range. Sensitivity rate, RANG, SR, 敏感度区间范围 for P1 unit profit for X1 is 30 through 80. That means if your manager asks you, oh, if we decrease price to 30, assume our solution, original solution, this solution. And manager asks you, what if we decrease price of product 1 to 30? What's the solution? The same, because it's within a range. Right? So this chapter, we use computer, it will tell us the range for each coefficient. For this coefficient, But unfortunately, the QM4 window is not so powerful, so it can only tell us the sensitivity range for this P1, for this P2, and then this and this. If the parameter change this coefficient, QM4 window cannot directly tell us the answer. So you have to rerun the software. You run the first time you run the original solution. The second time you run the modified model, and you compare the result. So it's all about this chapter we learned. 好了。 In Chinese, a QM4 window 它只告诉我们那个敏感度区间是目标函数的系数，还有限制是不等是右边的区间，它没有办法告诉我们限制是不等是左边的系数它敏感度区间。所以如果有题目问你这个的话，很遗憾的你就必须要跑2次，第一次跑原来的，第二次跑改变后的系数，然后去比较。That's all about this chapter. Okay, let's see a very difficult example. Not so difficult. Not so difficult. I hope. Okay, we will use the same example, either free example. First, as usual, we find a common area for all the model constraints. This is the solution area. First line, 40, 0, 0, 1. The second line for constraint, 30, 0, 0, 40. Okay, the feasible solution area to find the intersection of here. So we now do the sensitivity analysis. When doing sensitivity analysis, we choose which parameter we will change. We focus on one change. This time we focus on T1 change. And this is T2. T2 assumed to be not change. Even T2 50, we focus on whether the change of T1 will change the solution. 所以这样假设就是 T1 不变，这是50啊，然后看T2 不变50，然后看 T1 变化，怎么样的情况下会改变解。Okay. First, we calculate the slope for each line. This is for this constraint. This constraint, the slope. This constraint slope is minus 0.5. And for this constraint, the slope okay. And for our objective function, the slope now we focus on the change of the parameter in the objective function. Now the difficult part begins. In the original one, solution, which solution? Our optimal solution is, remember, point B. This is the original optimal solution. And if the slope of objective function change, if the slope is equal to this line, if the objective function slope is equal to this line, so the solution will be B and C. But if the slope of the objective function becomes more steeper than this line, then the solution will change to point C. So we cannot, the slope for the objective function cannot be steeper than this, or the solution will change. Okay, we think another way. If now the slope of the objective function will become flatter, 变比较平. This now is the same as this line. 盯着那个目标函数的那个斜率跟这个比较平的线是一样的。So the solution will be point A to point the line AB. But if the slope keep going flatter, 变得更平, the solution will be point A. Will change. So in your mind, you see, oh, we have a range. You can calculate that range. So let's see. Okay, I need a slope change of the objective function. How to change the slope of the objective function? Change P1 or change P2, right? But for the simplicity, 简化, we now focus on P1 change. P1 change. Okay. Even P2. Now the same. C P1 change. So the slope of the objective function is 50 P1. Difficult, this part is difficult. Because we have minus, we have sign, but actually we don't have to care about the sign. You just use the absolute value. Because the absolute value of the slope is high. That means slope is steep. 就是斜率绝对值越大，代表什么？越陡。记得这个越陡，斜率绝对越小越平。So we now focus on absolute value. This is the objective function slope, right? Now, like I said before, if the slope of the objective function is steeper than this line, steeper than this slope, the solution will change to point C to remain equal to point B. We cannot, but objective function slope cannot be steeper than this line. So and we have another part, right? If this slope of the objective function is become flatter, at most it can become, the slope should be equal to this line, If it becomes even more flatter, the solution will change from point B to point A. So it should be greater than equal to this. Now we can solve P1. Notice we have an assumption. We assume T2 not change. This is the assumption. We focus on whether T1 change. So we calculate the sensitivity range for T1. So let's calculate the range. If we focus on these two parts, and we can shift the what's this? 3/5. What's this? And now we focus on these two parts. So we combine these two range. We will see P1 is the value between 25 and 66.67. So it's one way, the usual way to calculate the range, sensitivity range for the coefficient in the objective function. Very easy. But if you use computer software, you can calculate the answer in just a second. Okay. This situation, we focus on P1 change and even P2 not change. So we can think another situation. T2 change given P1 not change. What's the answer for T2 sensitivity range? If you are interested, you can calculate this. And next period, if you tell me the answer, let's go 3 cards. 看谁算得出来就给3张，上节课上课我会讲。And now, I distribute this table. Please sign your name. 我要发这个座位表，就是签一下名哦。按照你现在坐的位置，就签个名。现在学校要写那个。Take a break. 这是怎么睡？我认识。